Okay, guys, welcome to this second live stream on Vsynth. This time, I'm going to be answering some questions regarding my port of Vsynth into Spark AR Studio, which was a request I had on my Patreon, which is only about Vsynth, it's not about Spark. So here you're watching a Vsynth patch inside Spark AR Studio with this new render pass feature, which was released last Wednesday, and I've been beta testing for the last couple of weeks. So I first want to say that I use Spark in a very personal way. So there are a lot of stuff that I achieve in one way that are totally able. I mean, you are able to achieve it in other ways. It's no need to copy what I'm doing. So let's begin. So if there's anyone here that don't know what Vsynth is, so Vsynth is high-level module video synthesizer I'm developing for Max MSP, which is a 30-year-old programming environment for multimedia. So the community is huge. And well, I've been using Max for 10 years now. And well, Vsynth are this series of modules. Then when you start plugging them together, you can create different visuals and achieve different aesthetics. For example, I'm going to turn on the camera now, and there's me, and there's some sine waves there. So, well, this is pretty much Vsynth. This is Max. I'm not going to be talking about in depth about Vsynth, but definitely my workflow is to start patching in Vsynth and then go to Spark and try to do the same thing. So let's have a look a little bit on my Instagram. I have here a reflector to copy my phone screen. Just wait me one sec. All right. So this is the Vsynth Instagram page, and as you can see, Vsynth is all about creating this kind of generative graphics, and in a way, I mean, with video synthesis logic instead of thinking on SDFs and different things we have in Spark. I think everything as waveforms and frequency and different parameters and things that branch from video synthesis. So let's take a look at the filters. So these filters haven't been updated in a while, but let's check out the Square Wave Night Instagram filter. So basically here I have, this was my first filter. And here I have basically the webcam displacing some stripes, which for me are named as square waves. And here we have, different styles on the same thing. So for example, how I did this. So let's go a little bit to Vsynth again. And this one, for instance, it's more difficult to make in Vsynth than in Spark, but let's have a look. So I have my webcam here. I have the webcam there. Awesome. And I have the square wave already. And as you can see, I mean, if you never use Vsynth and after this video you want to start using it, there's even an example. The first example of everything in Vsynth, it's actually really similar approach on the filter I've just shown you, as you can see here. So let's make the actual filter. And to do so, I'm going to grab 3 oscillators in square wave and the RGB mixer, which in Spark would be something like the pack 3, or yeah, it's like the pack 3. So each of these waveforms are going to be feeding the R, the G, and the V channels here. Let me just stop this. And here I can change the stroke width, or in my case, since I'm using Vsynth, syntax would be the pulse width. And basically, what I did in that filter is to displace the coordinates of the stripes, right? So, I mean, it doesn't even matter if you don't have a square wave or something like that in Spark. You can create an SDF and a simple stripe and then displace the coordinates of those stripes with the camera, which is what I'm gonna do now. Okay, and if I put the same frequency for everyone, you can see I can displace a little bit there the colors. And let's give some movement to this. And there I have pretty much the filter I just showed you. And we are going to go to Spark just in a minute. But for example, I don't know if you remember, but the second preset of that filter, it is basically this, which is the, instead of diagonal stripes, I will have vertical stripes. And they are going to move fast. And also the stroke width is a little more. Yeah, so that's the second preset, for example. So basically, I prototype all my stuff here, and then I port everything to Spark. So let's grab Spark again and go to the actually the project on this filter. This is Vsynth online filters. So the square wave night filter is this. I don't remember if this is, this is version 54 of Spark. I think this one was done with 66, so it's gonna be any problem. Yeah, okay. So here I have the Spark session, and as you can see, this is pretty much the same as we have in Max. And I have here my square wave, which it is basically the same as I was showing you some minutes ago. So here I have my square wave, and then I displace this with the camera, and I got this. So as you can see, instead of having the full oscillator as in Vsynth, which, I mean, here in Vsynth, it is important that I have all the waveforms in my oscillator, because I use this to create different generative videos. So, suddenly maybe I want to have a sine wave, but then I record a preset, and then I want to change the waveform and record another preset. And well, basically that's why I need to have all my waveforms, to have packed in a really little module a lot of different possibilities. And there is an interesting fact here, which is that under the hood, each oscillator, is generating just one waveform. So even though you have here a lot of different options, inside the module, we have actually executing just one waveform. And this is why I didn't port my waveform generator exactly the same in Spark, because as you can see here, I only have a square wave. I don't have all the different waveforms. That's because in Spark, I don't know any way to say to the patches to stop executing. So if you have 20 patches in your patch editor, you're going to be executing all those 20 patches. So for example, here I have all these square waveforms, all these presets I have here go into a texture picker. Let me just show you all these different presets, all are being executed at the same time, which is not the best. I would like to stop the other presets. But yeah, so that's something I can do in Spark right now. So that's why I have all my different waveforms into different modules. And going further, here I have a square wave, which has the angles hard-coded with another patch, which is the texture patch. Here I can change, for example, the diagonal stripes to vertical or to horizontal, or came back to the diagonals. But for example, I have now newer square waveform modules or patches, which instead of having an input for the texture coordinates, have an angle parameter here. So I can basically change by hand the angle of the stripes. But anyway, as I was saying, you can replace the square wave with an SDF. I think there is something like SDF line, maybe. Yeah. So most probably you can change what I'm doing here with SDF. I'm not used to work with SDF. That's why I build basically the whole Vsynth into Spark to have my own workflow within this framework, to work comfortable with the stuff I know. So yeah, so that's why I start making all these different patches. So this is the square wave. This one is pretty easy to make with other modules instead of mine. But there are others which are more complicated to achieve with standard Spark patches. So, for example, the pop punk filter, it is pretty simple. It is just a step function. As you can see, I have here a vertical slider to change the threshold. But here it is pretty much, well, I call the step function a comparator. It's also called a keyer. But inside the comparator module, as you can see, I have pretty much a smooth step. And then I have two variables. One would be the threshold, and another would be the smooth. But in this scenario, I can simply write step, and let's say 0.5, and that's pretty much the same as I'm doing here with the smooth step. But I added basically two variables. One would be the threshold, and the other would be the smooth. And you can smooth there the step function. So, but for example, here in Vsynth, it's pretty straightforward. I even have a lesson which teach you how to make the pop-up filter. I think it is in here. Here I have the pop-punk filter, and as you can see, it is pretty much the same as in Spark. But basically, I have my own module, so that's why here it says comparator instead of saying step or smooth step, because I'm using here the modules that then I port to Spark. Yeah, so one of the things that came out this week, which is render pass. It is pretty great. We are all pretty excited, and I've been beta testing this for the last couple of weeks. So here I have some tests I've been doing. Again, these all really branch from Vsynth. For example, let's just go to the SlitScan project, which, I mean, it is pretty trendy at the moment. All right, so well, I mean, this is pretty simple patching. Maybe it's not clear in Spark because when you are doing feedback, you have the frame delay, and then you have to go, back to receive the frame you are delaying. So I'm gonna show how to make the SlitScan with Vsynth in order to make the chain of processings more clear to you. And this is something like this. So I have the camera, and I would like to grab just a little portion of the camera image. So I'm going to grab again a square wave because it gives perfect and sharp stripes. So let's do something like this, and let's start moving. Awesome. So now I can multiply the camera image with this square wave or with this stripe. So let's grab a multiplier. So let's multiply there. So now I'm multiplying the camera with the stripe of the square wave, and I have this little scan line going through my screen. So now one of the things you can do here, it's what's called a luma key, which is cut out the blacks and replace them with another video source. In this case, I'm going to be replacing that video source with the same frame delayed just one frame. So let's grab a luma key here. And I'm just going to grab another video source like a color solid generator in order you to comprehend this. So now I'm replacing the blacks with red. Okay. And what I would like to do is to replace this with the same image. So you can see here, I'm going through the luma key, I'm cutting out the blacks, I'm going out the luma key, I'm just storing a frame. I mean, I can delete the displacement module, which is something like that in Spark it's called texture transform, and I can go like something like this, which is a simple pass. So the texture is just passing through that module. And as you can see, I have here a pretty straightforward SlitScan. There are more ways to do this. For example, I can delete this pass and grab the displacement again and do the same connection we were doing. And instead of moving the scan line, I'm going to stop the scan line. So now the scan line is on the top of the screen. So you can see that's the scan line, the white scan line. I'm gonna leave it there stopped without moving. And what I'm going to do is to displace downwards. I'm going to displace downwards the image, the live image that you can see really little going into the stripe. So I'm going to displace downwards with the displacement module, and this is going to be something like this. And here you have another version of the SlitScan, which it's a little bit different because you have to move and not the scan line. But the cool thing about this is that you can create several scan lines and pretty much have different slit scans in different sections of the screen. So I'm showing this in Vsynth because I think that the loop, it's more understandable here because you actually have to make this loop with the cables. And in Spark, you don't have that. You have a receiver of the delayed frame, which can be, really far away from the delay frame, and you might get lost with the with that kind of connection. So I think that here it's pretty clear how the feedback loop works. And yeah, so let's do this in Spark. We were already having this project here. Okay, so here I'm going to open this up. So here I have the delay frame, which I'm feeding to the first frame with the camera. And then I'm receiving the one frame delayed here. I'm applying no transformation here because everything is in the default values. And then I'm sending all this to a Luma key, and then to the shader render pass and to the feedback system. So the feedback system is pretty much done. It enters to the first frame, it goes to the delay, and it goes back here again. As you can see, it's not as clear as in Max, the feedback loops, but that's because Spark has horizontal patching and Max has vertical patching, and I don't know how they can make horizontal patching and I don't know, suddenly a cable that came out from the frame delay and you send it to the left. It's kind of weird. So they came up with this solution of the sender and the receiver, which is okay. And yeah, so let me just decompose this patch a little bit. So here we have the camera texture. And as you can see, I have here another square wave. As I was saying, for example, this square wave has an angle knob. So I can say, I don't know, 45 degrees, and the stripe rotates. So this is another simple square waveform that I have in Spark. I have, as I said before, I have several repeated patches because I don't know, in Spark it's really easy to create new groups, new patches, and because the final result is gonna be an Instagram filter and not live visuals, I think it's better to have a lot, but different little pieces of code or patches you can reuse. So that's the square wave. Then again, I'm multiplying here, so you can see now the scan line with a little live feed and the rest black. And that's what I'm sending to the source A of the Luma key, and to source B of the Luma key, I'm sending the frame delay. And once you do that, you replace basically the blacks of your screen with the same image, but delayed. And that's how you build this simply slit scan type of effect in Spark. So there's another way of doing this, as we saw earlier, which is basically stop the scan line, and now it's on the top. I'm going to change the camera to my actual camera, so you can see the live feed there on the top of the preview here. And then I'm just going to displace with the transform pack here the delay frame, and this is going to be 0.01 maybe. Oh, negative values. Oop. This is not working because I'm not visualizing that. All right, okay, so This is going to be 0.01. Yeah, so this is the other way of creating a slit scan. Going to change, I have here a vertical slider changing the position of the scan line, which now it's here. Right. And you can see these little stripes of my skin tone. And that's because the transform texture and the 2D transform pack work with the clamp bound mode, which I don't know why this hasn't the ability of changing the bound mode. So I'm gonna add here a patch of my own, which is it is shared for free, which is the clear bound mode, which basically instead of clamping the pixels to the bounds of the boundaries of the screen, it just shows black. So I should have here the clear bound mode. I don't know if this is going to work. I'm just going to assume it's going to work. I have a receiver here with the texture coordinates and the device resolution, which is, yeah, I think it's this one. And I'm gonna feed this to the screen size of my clear bound mode. The texture is gonna be the delay frame. And this is going to source B. And now let's say scale 1 and offset minus 0.01. And nope. Something is pretty strange here. There's something flickering there. Offset. No offset. Okay, this is behaving kind of weird. Wow. Definitely working a little funky. All right, so I mean, let me check. I have another project which is using this. This is in SlitScan 2, maybe. Yeah, no, I'm still using the transform 2D pack. Here you can see, I mean, this is pretty much the same as we were doing. And here we have two different stripes doing the slit scan, as you can see here. And then you get basically this, and then you replace the sections in black with the frame freeze and going downwards. And that's what we are doing with the texture transform patch here. Okay, I guess there are tutorials now about how to make the slit scan. It's a pretty common technique. I think it's the first thing a lot of people did with this new render pass feature. I really went in a different direction with the render pass thing, because one thing that is pretty common in Vsynth is to make phase modulation between oscillators, and this goes something like this. So you can see here, I have my sine wave here, and I can remember that the displacement module is pretty much the same as the transform texture transform in Spark. So I can go here and then modulate the coordinates of this sine wave with the same sine wave. So here the loop we are doing with the frame delay, receiver, sender in Spark, it is pretty much understandable. So I basically start doing that, and if I rotate the image, for instance, I get this kind of effect. And if I go more, I reach these weird noises doing feedback with this waveform generator, with this sine wave. So let's do the same in Spark. I have here one project to show you, which is the phase modulation feedback test. And as you can see here, I have my phase modulated sine wave. And to achieve this weird behavior in Spark, I did pretty much the same as we were doing. Oops. So I have here my frame delay. This can be, avoid for now. So I have here my delay frame, which should be receiving actually its first frame from the sine wave. And since the sine wave is a procedural texture, I need to add a shader render pass here in order to send that to the delay frame. Yeah. All right. And then I'm receiving the sine wave, which is this, guys. It is just this. It is just the sine wave, as I was showing you in Vsynth. But then I'm grabbing the delay frame and send that to a high pass filter, which is pretty much a sharpen. I mean, in other syntax, it's called a sharpen. Then I'm going to a blur, which is a low pass filter. And then again, I made a transform here to rotate and displace a little bit the coordinates of everything. If I rotate more, these kind of things happen. If I rotate less, that kind of things happen. And then I'm just distorting the coordinates with which I'm actually drawing the sine wave. And that's how I get this funky video feedback thing in Spark. That you can actually, I'm gonna share with you guys a link so you can test this on Instagram right now. Let's send this to the app. And I'm gonna share this with you here. So you can grab it, and I'm gonna show you again with this app how it looks on Instagram. Yeah, so I have now in Instagram this phase modulated sine wave with itself. It's not the most normal filter you will find on Instagram, but it's pretty funky. And I'm amazed because it's working really great, even though I'm using here, I don't know how many passes, but guys, I'm using a lot of passes here in order to get exactly what I want. So let's check that. So here I'm using 1, 2, 3, 4, 5 render passes, shader render passes. And, I think that in the high pass and in the blur here, I left more shader render passes because there is a thing with blurs that, it is better to have, or you can blur better an image if you have one pass on the X coordinates and then another pass on the Y coordinates, and you have to repeat that all the time. You need to repeat it in order to get the different effects. So for example, I'm starting here with an X pass of the blur with this amount, then I go to a Y pass on the blur with the same amount, then I made another 2 passes on X and Y with another amount. And the same goes to this other blur patch here. I have, so there are a lot of render passes actually in these patches in order to get everything working exactly the same as in Vsynth, which is not bad or not good. It's what it is, but I'm surprised that it works pretty awesome on Instagram. So let's save this. Let's go to another one. This one is also branched from one of the example patches in Vsynth, which is the finger feedback. Should be somewhere. It is here. Finger feedback. So this is another way of using render passes. So as you can see here, the feedback loop, it's done between a circle, this circle, and the same circle, but displaced, pass through a high pass filter or a sharpen, then through a low pass filter or a Gaussian blur, and then to a temporal filter, which pretty much interpolates the consecutive frames, which is basically grabbing a delay frame. I can do this something like this. I think the Spark tutorial on the delay frame goes something like this. Like you have the camera image, and then you have a mix or a blend operator, which I have both named, one as a crossfader and the other as the blend mode mixer here. The blend mode mixer. And then it's pretty much what we were doing. Just grab a displacement or something that delays the flow one frame. So this is pretty much the example that comes with the delay frame in Spark, which you need just to mix the camera original image with the delay image, and then you mix that, and the crossfade, it's pretty much a mix inside. Or then Spark also just suggests using a blend mode mixer or the blend module, which has different blend modes. So this is gonna be the additive, and as you can see, the feedback is doing the same as in Spark. It's taking all to white, basically. If you put subtract, it's gonna go to black. And you have the different blend modes here to work with. All right, so again, let's go again with the finger feedback. So I have here a lot of different actually convolutions. Inside the high pass filter, I might have something like 4 passes. So 2 X passes and 2 Y passes, and the same with the blur. And that's why it's called 4X, because it has 1 pass for X, 1 pass for Y, then 1 pass for X again, and then another pass for Y. So inside these modules, there are 4 passes, another, I think there are 4 passes also. So, there is a lot of passes and convolutions here in order to get this kind of reaction diffusion on Turing patterns in Spark also. So let's go to the finger feedback now. And this is here. So as you can see, it is pretty much the same. I have here my finger, and then every time I slide through this screen, I have this generative animation going on. So the patch is pretty much the same as in Vsynth. It's the same as I shown you. we have here a patch called the circle follow mouse. Oops, which is yeah, it's a patch I made, which it actually follows the mouse and create or the finger and create I don't know what it is. Okay, and creates this circle, and that circle follows the tip of your finger. So I'm sending that single circle here to the delay frame patch, and I have to put in between a shader render pass because this is not image, this is not a texture, this is a procedural thing going on in Spark, and in order to the delay frame understand what you're doing, you need to plug here a render pass. All right. So as you can see, I mean, the most amount of modules are in the feedback loop. So here I have my sender delay frame, and my receiver is like really far away. So in that sense, I really prefer, you know, having the loop in the cables, like I show you in Max. That's more graphical, and it allows you to understand better what you're doing. So I have my delay frame here, and again, I'm making some spatial transformations here, really simple. I can put this more like this. Yeah, it's going too fast. Let's more slowly. So there is something in the feedback loop that I didn't mention, which is that since it's happening so fast, if you use large numbers, it's gonna be really difficult to control. So that's why I'm using, dispersible numbers like 0.001 and that kind of intervals, because, as I say, the loop here that we can see because of how the patch works in Spark, but there is a loop going on. It's happening 60 times per second or even more. I don't know at what FPS Spark is working right now. Let's see. So yeah, it's working at 60 times per second. So that calculation, it's happening so fast, guys. So that's why if you put, like 0.1 here, you can actually see the different iterations of the loop. Whereas if you put really little numbers, you actually gonna have this behavior that I was looking for. And after that, it is all the same. It's just chaining a lot of convolutions. So I have here a blur, a X pass of the blur, then a Y pass of the blur, and I repeat that several times. And then I get to the step which I'm making the comparison between the original frame and the delay frame with all these convolutions chained. And then I pretty much basically invert the colors because this is what I was getting, and I wanted exactly the opposite. So again, I'm gonna share with you now the link so you can test this on Instagram. You can see it works pretty great. So I'm gonna grab this here. I'll let you in the comments. And I'm gonna show you now again how it looks, if you can test it. All right. So this is still working. That's awesome. Let's go to this new test filter. And yeah, as you can see, this is pretty interactive and it's working amazingly. I mean, it's really, really responsive. And yeah, I mean, there's no a lot of magic in this filter. There's no a lot of custom patches, difficult custom patches or anything branched from Vsynth. It's actually, a lot of blurs chained, and yeah, and it's pretty much that. The only thing you need to take into account is that you need to make different passes in the blurs, basically that. And to yeah, I mean, it's all really out there. It's a pretty common technique, this one. The only thing you have to take into account is to set the numbers correctly. So there's a lot here of fine-tuning the numbers in order to get this smooth behavior. Because, for example, let's do this again. If I change this and put 1.1, for example, now it's not that cool, you know. There are a lot of you can see every iteration there on the feedback loop, and that's not what I would want in my effect. I mean, this is not really aesthetic. So yeah, so that you can fix that by just writing a really low number, and then all the iterations are going to be really next to the other, and that will develop in this kind of effect. So here's the finger feedback. I'm gonna go now to I'm gonna go to some classic feedbacks, like really gonna show this again in Vsynth because it's much more clear than in Spark. Okay, that's me again, guys. Right, so I'm gonna grab the Luma key again, and I'm going to cut out the whites behind me, and I'm gonna replace that with the same image. Okay, I'm gonna in the whites, and this is something that you already start seeing a lot of people is making, which is a really classic video feedback technique, which is just feeding the Luma key with the same image. You know, you can add a displacement or you can't add it. It's the same. I mean, if I scale a little bit the image and make it bigger on each iteration, you can get this kind of effect. And if you scale it to the other side, you have these infinite trails of myself going there. And then you can, of course, send everything to the right, to the left, upwards, downwards. I mean, here you can just go nuts and try different processors. And that's what we are going to do. I'm going to, for example, grab a comparator, which is pretty much the step function. And it is here. And as you can see now, the feedback, it's all black and white. So I'm gonna do another really classic thing, which is to invert the colors of each iteration. So you can do that by simply inverting the colors in the feedback loop, and each time the signal go out from the loop, it's going to be one color, and then when it goes in again, it's going to be inverted. So it's we are going to get something like this. This is the way I invert in Vsynth this operator, the exclamation sign. It is pretty much what I'm doing here with the operator one is doing 1 minus in 1, which is this cable. I mean, in 1 is this inlet. So as you can see here, all the iterations in the feedback loop are now inverting themselves on each iteration. So the first iteration, it's white. The second iteration, it's black. The third iteration is white. The fourth iteration is black. And this goes on through infinity. As you can see here. Awesome. All right, so this is one technique. Remember this because we are going to be doing the same in Spark in just a few moments. There are other things you can do, for example, because the comparator right now is in black and white, but we can set it to RGB, which means that this threshold it's going to behave in the RGB channels. So every time the red channel go above this threshold, which is 0.35, it's going to be all red, and the rest is going to be black. The same with the blue, and the same with the green channel. And that's how it looks. I'm going to make the iterations closer, so we don't see all the different iterations, and we see the trails. So here we have the trails again. It's all really flickering because we are inverting the colors on each iteration. So this flickering is totally fine. So now let's, So now I'm displacing to my right a little bit each iteration, and then applying the comparator and inverting the colors on each iteration, and this retro feedback kind of thing from analog video mixers kind of appear, which is pretty cool. And I can make myself disappear completely in this effect. So this is a really, really, really common technique in video synthesis or in video. I mean, yeah, with people that use video mixers and make visual art with analog gear. So yeah, so we can have it now in Spark, and I'm gonna be showing this in just one sec. But here's how you make this kind of thing in Vsynth. Then another common technique is to add an edge detector in the feedback loop, which is what I'm gonna do now. I'm going to add an edge right now. And I got this. And there's a really cool thing about the edge, that if I add a blur before the edge, actually the edge detector is gonna work better, because, well, anyway, I'm gonna explain that in my Vsynth workshops, but trust me in this, that when you add a blur before an edge detector, it actually behaves better. So I'm gonna add a blur. I'm gonna blur the image a little bit. As you can see, automatically after I blur a little bit the image before going to the edge detector module, this kind of Turing pattern appears. And I'm going to slow down a little bit the motion so you can see it better. And then I'm going to scale this a little bit so it goes to to the front. So as you can see, it's really, I mean, this is really simple technique, which is basically grab a Luma key and feed it with the camera, and the second inlet of the Luma key, you replace it with the same camera image, but displaced, blurred, and then with an edge detector applied. And this pattern will appear always. And never mind the image. I mean, I'm gonna grab whatever video here I have. Let's go with the standard Max Vivo movie. And as you can see, with this video, the same behavior happens. So, yeah. So that's another technique that I'm gonna be showing in a bit in Spark. And again, we can click here and go from black and white to color. And yeah, we have this funky thing going on. All right. Okay, let's go to Spark and let's try to do this again. These ones are called classic feedbacks. So here I have my classic feedbacks, which again have this, I always work with a Luma key instead of segmentation, and I always have a vertical slider here to control the threshold of the Luma key. So as you can see, let's go again really from the basics. So we have the camera texture going to the delay frame patch. Okay, and then I have the delay somewhere. Here it's the delay. I'm making a really simple spatial transformation, which is pretty much scaling it a little bit. You know, if I put 1 here, there's no, wait, 0. Oh, I'm not using it. I'm using my clear bound mode, which is here. Let's connect this again. Well, as you can see here, I'm plugging the delay frame to a texture transform, making a simple spatial transformation just to the different iterations go, you know, to the infinity and rotate them a little bit. Then it goes through a render pass, and it goes directly to the second input of the Luma key. And again, I'm controlling with the slider the threshold on the Luma key, and I'm replacing the whites, in this case, with the same image, but a little displaced and rotated. And you can achieve this, this classic feedback thing. That's not rotated anymore. And as you can see, it is pretty much the same as I was doing before. All right, so let's grab here the delay frame, and let's invert it to see if we can get the same we were getting. Yeah. Okay, so I'm gonna scale this a little bit so it goes to infinity. And as you can see, there the colors are inverting on each iteration. And before the inversion of the colors, I would like to compare them, or pretty much add, instead of using the comparator, let's just grab a step here and put step 0.5. So as you can see, now I have that the same feedback we were creating with Vsynth in really simple steps with Spark, which is, let's do this again. You grab the camera text, go to the delay frame, then with the delay frame, add a little scaling, or just displace a little bit each of your delay frames, which are going to be a lot, as you can see. It's happening so fast. And then you just compare them with the step, and then you invert them, and you go to the Luma key. And if you don't have this patch, you can grab it for free from my Gumroad, and I guess people have already shared more Luma keys algorithm. So I have an invert here, and instead of replacing the whites, I can start replacing from the darks, and basically I can, instead of replacing the background, I can replace with the feedback the person. So I'm gonna grab the camera here so you can see how this works with me. And that is me. So now I'm going to start replacing the blacks and the darker colors with the feedback. And we can do this the other way around and start with the brighter colors of the image. All right. And okay, so yeah, so this is pretty much the really classic video feedback technique. I was using here my clear bound mode because it's because of the clamp I mentioned before. And let's see if now this works here in this setup. Yeah, so as you can see now, I don't have colors that are clamping to the boundaries of my screen. So when I scale this, let's see. So when I scale this, I have now all the squares to the infinity, and I don't have clamped values to the boundaries of the screen, which will create some vertical lines going, I don't know, maybe from the middle of the screen upwards. which of course we don't want that kind of things. Yeah, so here are some pretty basic feedbacks. Let's go to something more complex with the edge detector on the feedback loop. So I have a question now. I really don't know how to answer that question. How do I put to find this part for you? Mean here? Like, I know this comes with the Mac, man. Okay, so let's go to the edges feedback. Right. Okay. So this one is more complex. Once again, I have a Luma key, and with the mouse or with my fingertip, I'm going to control the threshold. I'm going to share this link with you guys so you can see how this works. Okay, you are on a PC. All right. So let me just, I don't know if I can left this all the time sharing my phone screen, but hey, okay. So I'm gonna go to Spark once again. And as you can see, oops. Yeah, so it is working pretty awesome here in the phone. Maybe I'm losing frames in this transmission, but believe me, this is really working smoothly. Really, really, really smoothly. All right. So again, here, it's not a really complex technique. It's just how you configure your different convolutions and how you, yeah, well, it's basically that. Which algorithm you are using with your blurs and which are the values you are setting them, and also the amount of blurs you chain together. So let's see what's happening here. So again, I have my camera texture going to the delay frame, and then the original texture is going to the source A of my Luma key, which means that that's the image I'm gonna start cutting the dark or brighter pixels and replace them with other video source. And then we have the delay frame really on my left, and again, a really simple displacement, coordinates displacement. Like I'm pretty much rotating a little bit this and scaling it, and not so many, complex stuff. Let's see what happens if I rotate this, I know, like 20. So you can see it is not that cool. And that's because, again, the iterations are really separated, and to get these effects, you need to have all the iterations really close to each other. So values should be really, really small. And again, you can see here all the clamping because of how texture transform works. I don't know how many times I asked this as a feature request, but the texture transform must have different bound modes. So clear, mirror, wrap, and clamp would be a really good addition to the texture transform. But yeah, you can use here the clear bound mode, or if you have purchased my bipolar displacement from Gumroad, you can use it here. I'm just trying to, in these examples, using all patches that you can borrow for free. So the blur is a patch you can borrow for free. The edge detector, I guess there are some already shared for free. So I'm gonna change again the rotation here by 2. It's a lot. Let's put 1. Okay, so I have, yeah. So the same thing, it's gonna happen with whatever feed or video source we plug, it is something that always happen if you chain the convolutions I'm chaining, and if you do this with a Luma key. I mean, this is not something super complex to get. You just need to know a little bit what you're doing and set the numbers in a proper way. So please remember that here you are working on a feedback loop, and that's happening so much fast, and you need really little numbers instead of numbers like 0.5. You want something like 0.5. You would want something like 0.05 maybe. Okay, so here I have my edge detector, and I can toggle my black and white or RGB edge detector, and I can, for example, change parameters here. Like, I don't know, I'm gonna put 56, or let's put here in the threshold 55, and as you can see, the feedback change, how it behaves depending the numbers I set. So this is kind of tricky. You really need to know or understand approximately this process in order to get the different techniques. Let's put, this is gonna be a lot. It's blurring a lot and making the feedback, like bigger instead of really thick. Like if I put here, I don't know, 0.5, or 0.1. 0.1, I ruin everything. Yeah, so here it's more thick. Let's try 0.3. It's blurring too much. But yeah, so it is a mix of convolutions and how you set those convolutions. And then after that, I have here some color processors in order to change the RGB to YUB color space, which is here. I'm not seeing that, so let's grab the RGB to YUB. And I plug here, let's put this more slowly, like 20 seconds. And here, besides the feedback is it's gonna change the color also with a different palette than RGB. So I'm showing all this stuff to you guys, but I haven't uploaded any of these filters just yet because I'm finishing my actual filters. These are just the tests I made while beta testing the render pass feature. So yeah, so I haven't released my filters just yet. So these are all my tests I'm showing to you. What else on Edge? So this is another, which is pretty much the same patch, but instead of having a Luma key, each time I click or each time I tap the screen, I trigger this feedback, which also has displacement. So each time I tap, I turn the feedback on off, and this kind of thing happens. And so this is already, I showed these ones, inverted phase. I showed the slit scans already. So this is another thing that was branched from Vsynth, which, well, it's pretty much you have this reaction diffusion system coming out from the edges of the image. As you can see, guys, I don't even have Instagram selected in these projects because when we were beta testing all these features, we weren't able to test this on Instagram. So you have to untick every platform in Spark in order to try the render pass function. So okay, so let me now send you this file or this link so you can try this on your phone. Let's see. And as you can see, it works really smoothly. I'm gonna go again and share my screen. All right, yeah. And as you can see, it works really smoothly. And it detects the border and starts the reaction diffusion system really smoothly. And this one was also branched from a Vsynth patch, which I'm going to show you. It's one of the examples that comes with my library. And it is, I think it's here. Cam feedback comparator. Yeah, so as you can see, that effect also branched from my Vsynth patch. It is pretty much the same as I was showing you. And as you can see here, we have again the feedback loop, really more understandable than in Spark, but pretty much I'm comparing or applying a step between the original frame and my delayed frame. Okay, so I'm stepping between those two. And my delayed frame, which is the one that's coming out from the OP2 and going to the displacement, once again, you can see I have spatial transformations, then I have a high pass filter or 4 passes of a blur, and then I convert that, I invert the blur to get the high pass filter. Then I have other 4 passes of the blur, and you can see how changing the value of the high pass filter and the blur, change a lot how the reaction diffusion behavior. You can create the blobs more bigger or or smaller, and you can make them move fast or slow, depending on how you basically configure or set all your different convolutions or blurs. So yeah, so that's one of the patches I was really interested in porting to Spark, and here it is. So let's see how it's done, and you are going to see that it's pretty much the same as I was doing in Vsynth, only taking into account that I have to chain the different convolutions with a shader render pass in between. And again, so here I have the edge detector. And this is fun because I can change the edge detector to work on RGB. So this filter also can have colors. But anyway, so I'm sending the image that comes from the edge to the delay frame, but also to the step, as I was showing you. And then the delay frame is here. I'm adding spatial transformation, then a bunch of convolutions, more convolutions, and then, doing the comparison between the original frame and the all the delayed chain here, which is pretty much the delay frame and a bunch of convolution chain. Yeah, and that's the output. And yeah, and you have this. It's all seriously. It's all really on how you configure the different convolutions. It's not that I'm creating something super complex here in any way. And I'm amazed that even though I'm using a lot of passes in the phone, it still works really awesome. Maybe the battery drains, but the the effect is still really fluent and fluid. So good work, all the team, all the Spark team on this thing. All right, so I have more stuff to show you guys because I've been doing a lot of these feedback experiments. Inverted feedbacks, okay, that's okay. So, reaction from edges. Right, so, okay, so we are heading to the end. I'm gonna open the mic if you wanna ask questions or anything like it. So here I have the VC reaction project, which is actually branch also from Vsynth patch, which is the VC reaction. And if you don't know what the VC reaction is, it's chemical reaction in which two, I don't know how to say this in English, two chemical components are oscillating between them. So you get this kind of spirals. There's a lot of videos on YouTube about chemical oscillators, so make sure you check them. But it is pretty much a video feedback technique also. And the feedback technique is based on the Luma key again. And as you can see, I have my spatial displacement here. And then it is pretty much changing the saturation of the colors and shifting the colors a little bit in the feedback loop. So let's do that and see what happens in Spark. And what happens in Spark, it's the same that happens in Max or in Vsynth, which is that the spiral waves start appearing when you configure everything the way you should configure it, so this behavior in the feedback loop happens. So let's see what's happening here. So again, the camera texture, it's going straight to the delay frame. And then the delay frame is again really on my left. And well, here I'm applying again my spatial transformation. Then I have a bunch of convolutions, my blur, more blurs. Here I have my hue rotation. And see what happens if I increase the speed. Nothing happens. And that's because maybe I don't have anything connected to the speed. Yep, I don't have anything connected to the speed. So let's grab here a runtime. And let's put here modulo 1. And as you can see, if this is going really fast, I'm going to multiply this by a number. So as you can see, if the rotation of the hue happens fast, you're going to get a flicker. I mean, and it's going to happen that. It's not that I'm inventing something here. It's if you rotate the hue in a feedback loop like 180 degrees, you're all the time inverting colors and you are going to get a flicker. So make sure, again, you just shift the hue really little, like 1 to 10 degrees, because on each iteration of the feedback loop, we are going to rotate that hue another 10 degrees. So again, so make sure you use little numbers here in the feedback. All right, and then I have here a Brucosa module. So if there is any Max user on the room now, you may know that I port also Max objects to Spark AR because, well, I've been using Max for 10 years now, so I'm really used to a lot of the stuff that comes with Max, and one of that is the load bank object, for instance, which spits a trigger on the initialization of the patch, and you don't have that in Spark. So I basically, for example, create a load pulse object for Spark, which would be the same as the load bank on Max. But for example, here in Max, we have some shaders that comes with it. And one of it's the Brucosa. which is pretty much brightness, contrast, saturation, you know, modulator. And so one cool thing about Max is that you can patch shaders also. So it is really straightforward to take patched shaders from Max into the Spark AR world. Because, for example, let's I don't know, Beck 1111 in Spark would be back 1111. So you have some different names, but in the end, it's pretty much patching shaders. So you can have here the mix, which is also available in Spark. We have here the Swiss, which is also something we have in Spark. So it is really straightforward to port some of the Max shaders to Spark, and this Burkosa, it's pretty much what I have just shown you, but in the Spark patching style. So yeah, so I have that. So I'm increasing saturation really little on each iteration of the feedback loop. Let's see what happens if I put 2 here. As you can see, I already fucked up here the feedback because I'm saturating it too much on each iteration of the feedback loop. And so to fix this, we have to change the saturation really little again on each iteration of the feedback loop, and we are going to obtain what we were seeing. Let's put 1.2, I don't know. Let's put 1.1 again. And with 1.1, we can see that the spirals kind of appear. So I'm gonna stay with that number. Okay, so I'm gonna send this again to you guys if you wanna test how this works in Instagram. And I'm gonna show you how this looks. Again, it is all really smooth. I'm really, really happy with the work the Spark team has put on this. 3238. Oh, okay, I'm gonna send it once again. Sometimes this happens. Yeah, right, and I have again here my my Luma key threshold controller, which is basically a slider on the screen. And yeah, and as you can see, well, in the streaming, this is going to be a little it's gonna be dropping frames, but it's actually looking pretty good here. So I'm gonna share with you again the link so you can try it out. And yeah, so this is the VC feedback, and it's pretty awesome. And then of course you can change the color at the end of the chain, which I'm not doing it, but for example, I'm gonna grab this and go something like this, and I'm changing now the colors and creating more crazy stuff. All right. And then my latest tests were something that I really don't like that much, which are liquifiers. But I can show you how this work. Basically, you have the image here, and with the tip of your finger, you can start you know, displacing all the different pixels and kind of draw or distort the image in several ways. For this, I'm grabbing the coordinates of the tip of the finger and pretty much sampling there and displacing the pixels from there. And this is a little bit the patching. And I think, oh, it wasn't in this one. Well, this one it wasn't that easy as the feedbacks, because the feedbacks, I mean, I'm doing something here that I'm not exactly sure if it's the right way to do it. With this delta thing, I'm delaying a value here and then subtract it to itself. I mean, this delay is dispersible, but it's not the best way to do this, I guess, in Spark, but it kind of works, so that's fine for me. But I think it's what's the second one, the Liquify 2. Well, shout out to Mark. Mark is my model when I have to make filters for several face meshes. Nico, what does it work with movie camera textures exactly? Okay, so meanwhile, Nico answered what he asked. Here I have another version of the liquifier. Oh, okay, now I see. So the liquifier only works with a static image, but you can see that each time I tap, I freeze the frame. So I tap, I freeze the frame, and now I can displace the image. All right, so why does it change? Okay. So, well, this is a better version, I think, of the liquifier. It kind of works better. I don't have anything here, guys. It's just really, I'm just sampling there and displacing. I don't have any blur or anything like that. But I leave something patched here so you can see what happens if I add a blur. And this has to be, of course, has to be. As you can see, now each time the image starts blurring more and more and more, and suddenly it's gonna be a brown or gray image because of the blur and the all the displacement I'm making here. So anyway, this is not something at the end which is cool. So I pretty much erase the blur from this patch and just go straight forward like this. All right. So that's the liquifier, and I create one which is more experimental, it's the one I like most on the liquifiers at least, which is I'm not only sampling but also moving the background, which creates a kind of DC effect, but I guess it's pretty fun also to work with. And you go something like this, and the image moves while you displace all the pixels. So if you want to try this one is kind of fun. Again, I have to add Instagram here. And here. Just wait me 1 sec. Let's see if this works. So each time I tap, I freeze the frame, and after that, I can start moving around my finger, and it starts liquefying the image while moving the background. And that's the end of the. And then you just, you know, I can publish these stories because my filter is not online. Anyway, so that's the liquefier. And I think that, you know, there's more to explore with the frame buffing and the render path thing. And one of the most expected feature was the ability to add a post-processing effect. And this is not something like super funky or anything like what I was showing. It is just, I have here, guys, one project with war helmet here, all right? And what happens if I want to add to the whole image a filter, right? Like a process. I want to blur everything. So we weren't able to do that, at least until last Wednesday, but now we can. And that means that there are a lot of assets that you might have bought or you might check in my Gumroad, which now can be really useful. For example, this is a helmet war, okay? And I have here some thermal color palettes, and I'm gonna apply that as a overall filter in my image. Like, it's like a post-processing. So the helmet is going to be processed as well. So I have here another object, which is the scene render path, which is grabbing, in this case, the whole scene. And that speeds a texture, and from that texture, I'm sending it to the thermal 2 color palettes, which is one you can find on my Gumroad, which is, you know, kind of a predator color palette. I have different thermal color palettes. I have here night vision, which is just green, it's not that funky. And I also have here scanline, which are these sine waves. Basically, I mean, I can have, you know, 10 sine waves. I'm sorry, this is not exactly as my oscillators. That's why I put 10 and I have only 2 cycles. So anyway, the scanline is basically to add that retrofilling of an analog TV. And so I'm going to add the X, I mean, the amount of lines I'm going to create based on the X resolution. So I have now here 750 lines, apparently. And all right, so then I'm going to multiply this scan line by the whole scene, and this is what I get. And what happens if I multiply this scan line by a thermal palette? You can have this kind of end to your, you know, to your war filter if you want. Or I know this is really fun to add post-processing effects to the filters. Are really amazing new feature. Thanks. I've been waiting for this since a lot. And another thing that you can do, for example, I mean, I have here something that has nothing related to Lego, which is, you know, this war helmet. But I'm gonna grab the texture of the whole scene, and basically I'm gonna send that texture through a Legofy patch, which basically turns whatever you feed it into some kind of Lego style thing. So yeah, so here it's me as a kind of a war veteran in a Lego world. I can extend here the amount of blocks, 30, 50, I don't know, 1, 2. But it's pretty awesome to kind of apply whatever you imagine to the whole scene. So this is pretty funky. So okay. Bye, Glitch. I just read your message. Okay, guys. So there's no much more I have to say. So if you want to ask something related to the render paths, related to the patches I've just shown, related to Vsynth or something else, now it's the time. And for the Vsynth users, I'm gonna be sharing some patches, some Vsynth patches branch from the Instagram filters on my Patreon. And yeah, so if there's no questions, I'm gonna be finishing this live stream for today. Next week, I'm gonna be talking about Vsynth and Lumen, which is a semi-modular video synthesizer. And anyway, just drop me a line, guys, if you have any question about how to create these feedbacks into